Today I'm going to present the runtime auto-tuning on behalf of Kevin Huck. It's actually work that I've been doing alongside Kevin Huck. He's not able to be here today because A&D won't provide him travel. So I also worked with Max and Jerry from Sandia, who worked with me on the Landice and Trilinos application. So I just want to give a brief kind of a background on how Kokkos has this tools layer that provides ability to talk with the Kokkos runtime. And there's two parts of it. It's the tooling infrastructure and the tool libraries. Tooling infrastructure is designed to be very fast. It's essentially designed with to use just a function pointer comparison for identifying active tools. So tool libraries, there are many. So in this talk, I'm going to focus on the performance tools, and specifically, there's a spectrum of manual to more automated and maybe AI-driven is what we're also looking at. And specifically for automated, there's the automated fixing or optimizing tools. And APEX is really the main tool here. In Kokkos 4.5, there was an auto-tuning. There are some new features that allow for tuning range policy, team policy, MD range policy. So the APEX is an online auto-tuning. So it's using tuning via the tool callbacks. So let me just go through this interaction between Kokkos and a tool when you do tuning of a team policy. So here's some code up here that shows the shows this basic parallel for foo, and there's team policy here. So what happens inside Kokkos? So what you first there's just a bunch of declaration and setups. So for what you're trying to tune, so the region label, region type, and then your goal, so team size, vector length, so the thing that you want to tune over, and then what the tool sees and does is it does all that setup internally using the tool callbacks. Then you're doing some setup of input variable values. You can look at the documentation on how this actually, how that setup works, but essentially it's just more setup that's then passed to a context, and that context is starting a new tuning session if necessary. So it's starting a tuning session within some particular region in the Kokkos code that, and then you're doing a unique search based on these variable tuple of values. Then the kind of the meat of it is getting the output variable value. So what is the best team, like the block size, team size, vector length, and then one thing is that it's doing this over. It's as you can see here, these are variable values. So these are over a normalized range, so 0.0 to 1.0. And so you're doing, once you have the team size vector length in this format, then you convert, and then you execute the loop, and that you do an end context. So it's essentially a stop timer in the tool callback. So for this, you need a Kokkos Tools Tuning API that's kind of a complement in Kokkos Tools so here's an example for a matrix multiply and an A100. All I want to show here is that through this, you can see the bottom, these three here, these are vector length. You can see vector length and team size. These are converging after a certain point, and so that shows the ability for this tuning to be that it works. and it works well. So it's not so this is really a test, and through this, it suggests significant application speedups. We did this work with a code called Mulu. We actually kind of simplified it a little bit with an avatar smoother. What we did here, and what the main point here that I want to bring up is that we're not only tuning over these Kokkos internals, we're actually tuning over the algorithm. So different kinds of algorithms can be, you can choose and find the best performing one. One of the challenges was doing distributed auto tuning that we came up that we found was a roadblock with the current tuning API. This is just build and usage instructions. Main thing is you got to use Kokkos enable tuning on when you build Kokkos. So that's important to make it actually work. You can look in the instructions here for more details. There's a lot of changes that need to happen to make this work better for the user. I am not going to go through all of them, but this is really the main thing is being able to do the whole process of defining these contexts and be able to allow the user to actually have more control over the parameter tuning. So like tuning over energy or some other, maybe occupancy tuning is something supported, but doing energy and occupancy together is something that we want to add to this. So multi-objective tuning is something that needs to be better supported. The last thing I'll just say is that once you have this tuning, you can do source-to-source translation to kind of add things like tiling or doing other code transformations, then tuning over those. This is some work that I've been trying to push forward alongside. So conclusion, APEX auto tuning, it's here in 4.5. We need more users, and there's a lot of future work and to go into. Thanks. And these are the acknowledgements.
Thank you, Vivek. We have time for one quick question.
Do you have any plan for if, say, like the vendor runtime has some adaptive optimization going on, having APIs or hooks for these to coordinate and not fight each other?
Yeah, that's definitely the direction that this is going. I mean, the uniqueness of this is that there is this is a portable auto tuning library. So it is meant to be, you can tune between different execution spaces. For OpenMP, there'll be a different kind of tuning than for CUDA. So yes, I'll just add that right now we're the only people that are actually. I haven't seen many vendors really get into auto tuning in the way that the way that we are in terms of online auto tuning. So.
It looks very similar to some of the stuff we want to do.
Okay, we should talk. Okay, all right, yep.
Let's thanks Vivek again.